All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of lightning talks in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants shares their knowledge on the latest technology trends in the industry. And this week, Ted Parton, who is an experienced senior engineer with us, is going to show us how to build AWS Lambda functions with Java. So as a lot of you know, AWS Lambda is a serverless event-driven compute service that lets you run your code without provisioning or managing servers. So let's learn more about it from Ted. Let's get it started, Ted.
All right, thank you, Parag. Go ahead and skip to the next slide here. So today, with our lightning talk, I've got three main goals I'd like to try to accomplish for everybody. And the first is to highlight some pros and cons of building a serverless application with AWS Lambda. And then the second is to demonstrate a typical Lambda function written in Java. And then lastly, I'd like to show you one that uses the Lambda Layers option. Which is really kind of a neat feature, which lets you make a dependency layer. All right, so first off, I want to start off, just in case you don't know what AWS Lambda is, in the most simplest terms, it is a serverless function, as Parag mentioned just a few minutes ago, and you do only get billed for your usage, and you typically invoke these through event-driven actions. Just like a function in any application, this function performs a fairly narrow focused set of operations. So the idea, though, is if you're building a set of serverless applications, is that you could have several of these Lambda functions working together in concert to make an entirely serverless application. Speaking of that, we'll talk about a few benefits here. So because it's serverless and the way that AWS Lambda is set up, you can do horizontal scaling fairly quickly. And there's a low initial cost. So your barrier to entry is pretty low. For example, the free tier, as a list here, gets you 400,000 gigabit seconds per month of computing, or 1 million free requests is another good way to think about it. And it is tightly integrated with a lot of their AWS offerings, like the Event Bridge, the simple notification service, S3 buckets, and so on. And you have support for multiple languages such as Java, C#, Go, and so on. So again, with it being functions, this kind of, as I said earlier, it kind of breaks it down to small little bits of work. So this, as I say here, encourages a greater division of the compute labor. And you can easily pair it with events to be for your serverless build. So for instance, in our workshop we did a couple weeks ago, we dropped a file out on a S3 bucket, and then a listener on the S3 bucket for the SNS saw that the file was placed there, and then it called over, or rather we had a Lambda listening to that or subscribe to the SNS queue, and it found that entry, and then it would process the file and place it into DynamoDB. And we'll see kind of a lightweight version of that today. There are some cons to using AWS Lambda. For the biggest one is vendor lock. So if it's always a concern if you go too heavily with one cloud provider, is that you could get a little too locked into their ecosphere. But if you're not worried about that, this can be a great tool. Another potential con is that it might be difficult to switch to third parties. Your Java functions in particular can go cold, but this can happen with any of the Lambdas. And when I say cold, I mean that first time they run, they're kind of slow to initialize. And if they're left sitting around too long, that first time it fires back up after a day or two could be also kind of slow. The other thing is, for a complex application, this may not be the best fit, but I think you can mitigate that by having really good documentation on all the different parts of your serverless application. So anyways, I'm going to move on now to our first Java-based Lambda function. And as part of that, I want to tell you a little bit about the setup I've done for this and what this function is going to do. By the way, if I'm speaking too fast, please try to let me know and I'll slow down a little bit. So first off, in this particular case, we're going to take in a JSON object that looks like, that defines some automobiles. And then we're going to process that into a DTO in our Java object. And then we're going to store that to a DynamoDB instance. And I'm going to upload these and show you everything in the AWS console. You could do this from the CLI as well. And just a few notes on my project setup here. I'm using IntelliJ. I've set this up as a Maven-based project and targeted at Java 11. And you can use Gradle. I just normally use Maven. But again, if you're using Gradle, you can do these things as well. Let's see. Lastly, and probably most importantly, there are some Lambda dependencies you've got to include, as well as the Maven Shade plugin. And I'm going to show you those really quick. So, and this little snippet here comes directly from Amazon itself. So you need at least these three dependencies. Well, I say that actually you don't need the log4j if you're not going to use the log4j logger, but it's a good idea to have it. But there are a few dependencies, so you've got to have, especially that Java core, the Java events. In our case here, we've got one for DynamoDB that I can show you in just a minute as well. In fact, let me see if I can tab over to that really quickly. And yes, here we go. And you can see here, I've got the SDK for DynamoDB, right? And I'll go ahead and show you this next part too, which is in our next slide, and that is the Maven Shade plugin. This guy. Actually, let me switch this to a better view for you guys. So that may be kind of small. And let's hit presentation mode. So it might be a little bigger for you. So yes, our Shade plugin. What this does is it actually pulls in a whole bunch of different pieces that may be needed, a bunch of dependencies that you know, the AWS dependencies would need. Things like maybe the Jackson piece will be pulled in. Now, as a result of that, your jar file becomes really big, and we'll talk more about that in just a few minutes. Here to this. All right. So next, when we're coding in this, typically you're going to use the AWS request handler for your any inbound request. You can look at this little code snippet I have here, and we wrote in this class is save automobiles handler, and we've got, it's going to come in with an input stream, and then we have on down here defined a handle request method, which I'll show you us calling that in just a minute. In fact, let me shift back to the code for that, and let me see if I can flip out of my file here. Sorry, gang, hang with me. Okay, so, whoops, that's the wrong one. Here we go. Okay, and I'll try to make this bigger for everybody. So you don't want that one, you want this guy. And okay, so here in our code, and you see IntelliJ's even identified that this is a Lambda. It's got the Lambda icon by here, right? And so in our class for save automobile handler, we're going to implement the request handler. And then that's defined as the input stream and Boolean. And this Boolean is actually what we're going to return on our call when we call our method handle request. Right? So in here, we're just going to do something really simple. We're going to take an input stream. we're going to use, we're going to map that on over to our automobile DTO, which you might see there. And then, and we're going to do a few little checks here, right, to make sure everything looks great. And then we will go ahead and persist this onto the database. So I won't bore you guys with that. Let me exit out of this part. And we'll flip back. Give me just a second. There we go. All right. Okay, so I've already started showing you the code, but let me shift over to probably the more impressive thing, and that is in our Lambda itself running. And so I've already set this up. So in my AWS Lambda console, now granted, I'm assuming you already have access to this. There's a whole bunch you have to go through to set one of these up in terms of having permissions and all that kind of thing. But we'll just show you really quick this Java standalone import autos. And also let me flip over really quick. I just want to show you, I have a DynamoDB table set up called automobiles. And here you can see some data that I've already populated. And I'm a big fan of Tesla, so I put a few Tesla cars in here. These are all original Roadsters. But then we'll go back over here to our standalone Lambda. And by standalone, I just mean I haven't included any layers in it in this case. And if you haven't ever been in this, it's kind of neat. For Java, you actually want to upload from a file. And so I've actually already uploaded the file here in this case. But just to show you really quick, you would have a little piece like this. You could go in and to your files and upload it. I'll cancel out for now. And then I'll actually tell you like your package size. So if we look here, it's 9.8 megabytes. Again, it's really big because of that shade piece that's pulling in a lot of the libraries and code that I think it's going to need. Because when we run our Lambda, we've got to have everything packaged up that it potentially needs. And so that's going to make it a little bit big. But my solution for that is going to be layers, and it's going to help us reduce that size. So in addition, we have our runtime settings. Here, I've indicated what handler we're going to use. I'll just go to the editor real quick. So in this case, in my source code, I'm in the com.InRhythm. You may recall I had the save automobiles handler class. And then now here's my handle request method. And now in here also, when you set this up, you can tell it what runtime. Now, as you may recall, I said we were targeting Java 11. So I went ahead and picked the native one here, the Corretto. And I'm just going to leave it at the x86-64 architecture. Right, so we've got that all set up. And now I want to run a test. So we can come over here to the test tab. And I've got a couple test pieces already here for us. And this is something else that's really nice is if you want to create a new one, you could click on this create new events and you could rename this piece if you wanted to, or you can edit a saved one. And you can also have multiple pieces. Now this particular one, I only have this one example, but I'm going to hit test. This will take just a moment to run. Like I said, it's probably a little bit cold right now, so this first run will be a little bit slow. And if everything turns out good, this will be green. So it's kind of greenish color there you may have seen. So it succeeded. If it had failed, it would have been kind of a light reddish color. Now in this case, a success doesn't really print out anything. If I go to the logs, I think it'll get a true as my Boolean value came out. And as you see here, we were trying to add in 3 Teslas, Model 3s, one that's purple, lavender, and violet. I'm going to flip back over to my DynamoDB, and you may recall I only had some Roadsters over here, right? But now I'm going to rerun a query. And if we come on down, now we have 3 Tesla Model 3s, the purple, lavender, and violet with the prices. All right. And we could change this really quick. You know, maybe I want to have one that's yellow and another one that's green. And so an interesting thing is, see this ID is 310021 and 31000022. If I don't change those, I believe they're going to be, it's going to overwrite those. So let's try that. This run should go much faster. In fact, it's already done. And we'll refresh our data set here. And here we see 310021 overwrote yellow, and the other one for 22 wrote green. Right. So that's just a real simple Java one. And I'll switch back to the code for just a minute too, to show you a little bit more of that. And just to give you a better setup. So again, POM file came in, had a dependency for a JUnit. And I just did a very simple basic Maven project when I came in. I have actually 4 AWS dependencies here. So the SDK for the S3, because I was, this project also talks to S3, the Java core, and the Lambda events, and the SDK for DynamoDB, and again, that shade plugin. And in addition to this save automobiles handler, there are a couple other methods I have in here. And if anybody wants, I can share my code repo with you so you can look at this a little bit later. But this is all fairly basic pieces. We have a little function to do persist to the database and initialize our DynamoDB, that sort of thing. All right. So I'm going to return back to our presentation for a minute and start talking to you about Lambda layers. So as you may recall, our first example of a Java-based Lambda came in at almost 10 megabytes in size. It showed up, I think, 9.8. So with layers, though, we can split out the dependencies. We can have kind of multiple layers. And by splitting this out, you'll see that our function will go down to about 21 kilobytes. However, we still have one layer or one jar that will be close to 10 megs. So now splitting these out can be a little bit tricky because you've got to do some things like build some abstracts that you want your main functions to call. But effectively, you write for what we'll see here. You'll see that we have 2 different jars. So the first one will be very lightweight, and this is going to have our base level dependencies. So again, we'll do a simple Maven project. In our POM over there, we're just going to bring in the minimum pieces we need, and we can we'll write a couple of abstract classes. One that's going to handle input stream types, and another one that takes in I believe it's just a string, but we'll see that in just a minute. And then we'll also look at installing this to our M2 directory, or rather, you'll need to do this if you're running locally to do your import. And lastly, you have to zip up this jar file to upload to the Lambda Layer zip manager because it does not accept just a .jar. It has to be a zip. And here actually is a real quick example of an abstract for input stream. So here we'll see we've got an abstract Lambda input stream wrapper is what I called it. We're going to implement that request handler that I mentioned earlier. And then we have, we're telling this that we're expecting inbound and an outbound with this I and this O. And then that we're going to have one public abstract method, which is the handle request. Now you could actually write more here. You could have a whole little function if you wanted to. In this case, I just wanted it to know that you've got to have this and let my code actually write in the details and do an override. In fact, I'll switch over and show you that. Let me get the right one going. And okay, this real quick is no, that's the wrong one, I think. Okay, here we go. And can someone tell me if that's too small or if I need to increase the font or anything? By the way, I can't see the chat window right now, so if
I'm on my phone and I can see it.
you can see it? Okay, great. Okay, so you may recall I talked about having these dependencies. I've just moved those into the POM here for the Lambda layer. Actually, I'm going to pull this out, show you real quick. In this setup of my code, I actually have two projects in here. One is for my Lambda demo library, which is what this POM is for. And then I also have the Lambda S3 processor, which is similar to what I showed you a few minutes ago. In the library piece, though, I've got our input stream wrapper. Again, what I just showed a cutout of, a screenshot of. And I also wrote one for a DTO wrapper. And the DTO wrapper, actually, instead of a string, it's of object to object, right? And then, so let me show you now over in my Lambda processor, I'm going to actually include this whole Lambda layer as a dependency. And so for our processor here now, our dependency becomes much smaller. It just has the JUnit and it has our Lambda layer. And so you may recall earlier that I said you've got to install the Lambda layer to your local M2 directory. And just really quick, the way you do that, especially if you're using IntelliJ, is you can just do a install over here. So when like we could do a clean and an install, and that'll copy it over to my .m2 folder for my local libraries, right? And then when I include this dependency, it will start seeing it. Now, something that's very important here is the scope. And there we want to say provided. So the reason we want to say provided is because we do not want Maven to package up this dependency inside of the jar it's going to create here that we're going to later upload. Because if we do that, then it's going to blow back up to like 10 megs roughly, and it defeats the purpose of the layer. So the idea with the layer, though, is that we're going to upload that jar for the layer in one spot, and then we could have multiple functions all utilizing that same layer. And then I'll also show you just really fast how we're going to implement that here. And so our save automobiles in this case is going to use this abstract Lambda input stream wrapper. And you may recall previously we used the request handler. But in this case, we're going to call the abstract from our layer. So it's going to make this available to use that handler. And then we have our handle request that we've overridden. And then one thing we're going to do is come in here. We'll take that input stream, we'll convert it to a DTO, and everything else will flow just like it did earlier. With this being the key difference is that we extended the abstract here. So now let me shift out. So back to the presentation for a minute, just in case I missed something. I want to show you. Oh yeah, so this is exactly what I was showing you a minute ago, the dependency and the actual Java function now, or Lambda function, is much, much smaller. And also, I just want to tell you real quick on this Lambda layer, and if you guys want, I'll show you this on from the command line myself, but when you upload it, you want to have your layer, your jar file, go into the Java lib folder is probably the best place to put it. Because the layer is going to be included first when in the little VM that AWS Lambda will run this in. That's going to be on your path, so it's going to have access to that jar. And so when your function goes to fire up, it'll then have access to this piece, and then so your abstract and all the dependencies that you have in that layer will become available to your main function. And you need that. So if this isn't in that location, if it's not in a location that can be seen, then you'll start getting exception, not found errors. And so that would be bad. So what I just did is after I compiled it, in fact, I'll just switch over and show you guys this. Let me get the right one here. Handler. Yep. Okay. So you saw a few minutes ago, I compiled. Let me see. We'll go here to. Go to my Lambda lib. And so I've created a folder called stage. And I'll show you real quick in my, let's see, I think it was in the demo lib target. You will see I have a Lambda demo jar, right? And it's actually coming in about 11 megs. And then so what I did is I'll do that, and I'll just redo that here. Is we'll do a zip. Well, actually, before we do that, I'm going to copy that. Actually, let me do it this way. I'm going to put that into this Java lib. It should be there. We're having trouble typing today. Oh, my bad. I forgot the stage. All right. Go into my stage real quick. I already have a zip file here, but I'll redo this just for demonstration. So we'll do the Lambda, and I'm just gonna put that into my file. Right, got that there. And now if we go to, let me see. Sorry, I'm trying to find the right window here. Oops. Hopefully everybody can see my browser now. So back here in our Lambda manager, we have a layers. Now I've already created this one time, but I'll go ahead and create it again just to show you guys. So call that live Java Lambda layer. Having trouble spelling today. All right, so again, it needs to be a zip file. And let me see, I'll go over here and I just got to move over to my, oops, wrong place, to my projects, and I'll upload this. I got that. All right, then I'll target. And also you can tell it your runtime. Again, we're going to pick Java 11. If you have a license, you can put that in there. We'll create it. So this will take just a moment. It's usually pretty fast. And so now we have a version right here, which is great. And also if you as you're making changes or iterations, you can also go back and you can create versions. So you can have a different version of it. And it would have a different number whenever you create the version. So in fact, I'll go back and show you real quick. Now notice that sometimes the screen here kind of caches. But if you look here at this common Java Lambda layers I uploaded last night, and it's showing that we have 3 versions of that. That's where I was kind of playing around. So now we'll go back to our functions. And so I've already created a version of our function here with a layer. And you look here, you can see this layers and it says 1. And there's actually a layer section on down here. And so it's also important to note, like, as you have different versions of the layer, so you can see here, we've got our name for the layer, what version it is. So as you play with this, if say I made a version 4, my Lambda function is not going to know that 4 is already here. I have to actually go in and edit that. So we could go in here and we could select it if we had a version 4. I could do that. Right. So in this case, actually, and you can also go back. You can delete these, and it'll go back version 1s. We could add a layer. So like we could come in here and add one that I just added. And if so, I would pick that one and I would tell it which version. So for the purpose of this, though, I'm going to skip that. I'm going to cancel out. We don't need 2 versions of it. sorry, I'm going to come back here. And so I wanted to show you the package size right now. See, this is 20.6 kilobytes. Now that we've separated the two of these, right? So this comes in really handy as you start having multiple Lambda functions. So we'll come over here to test though, and we're gonna have some records. I've got some Model Ys all set up for us. And we got them with red and white and blue, I believe. So we'll hit test. Again, this first one is gonna be a little bit slow because it hasn't run in a while. All right, so success. We'll refresh our data set over here. We can see our Ys came in. Boom, boom, boom. It's all looking good. And give me just a second. Sorry, folks. All right. So it actually is pretty easy once you get it going. But the tricky parts again is let me go back here, back up just a little bit. Is going to be that you need to create some abstracts so that your functions can access that base layer, and you need to remember to include those base level dependencies. So all the research I did, everybody seems to say like you want to keep your layer as kind of thin as possible and as little as possible. But if you are going to put things in it, you want to put things that are going to be utilized by several different Lambda functions. So, for instance, if you had a custom property handler, that would probably be something that you want to put there. I think I also put in the JSON dependency so that I could utilize that. Anything that you're going to use quite a bit is you want to put it into that Lambda layer. And let me see. So now I want to open it up to questions. If anybody has any questions, I'll be happy to try to answer those.
Yeah, I've got a question. So I'm curious, in your experience, have you had any complex multi-Lambda projects that required you to re-architect how, or to think deeply about how you partition the code for each Lambda?
Hey, Steve, it's Steve, right?
Yeah, it is. Hey, Ted.
Yeah. Sorry, I can't see the people right now, so in full screen mode. But yeah, I thought that was you. So actually, I have not built any full-on applications in Lambda for our clients yet.
Mm-hmm.
So that's a good question to think of. But one piece I didn't show you is there's actually an application section in the Lambdas, which I believe will let you coordinate several of those together. And I was gonna say, if you don't mind, repeat part of your question for me, and maybe I can maybe I have an answer for you, or what I think would work.
Okay, I'm gonna lead you a bit on the question.
Okay.
For instance, AWS SAM. I don't know if you've okay, so if you've used that, the application model that the tool is actually geared for is one in which you have one artifact per Lambda. Mm-hmm. So SAM will do this for you automatically, and will expect to find a single POM file per Lambda, and so that it will you treat each Lambda as its own project, and it will automatically descend into each directory, find the applicable project model. It could be Maven, it could be Gradle, it could be whatever other project model it supports. Right. And it will automatically build that project, which is a single Lambda, and package it up and upload it for you and do its thing. So it seems that SAM and checking out some of the pros on SAM. They have I think there's like a YouTube page or something or YouTube channel that has a lot of SAM stuff out there that they actually recommend a single project per Lambda. Now I've tried a project which was a multi-Lambda project, and it was complex, where we did not do that. And what we ended up with is a pretty substantially big artifact, kind of like what you were just talking about.
Right.
And so I just wanted to know whether you had tried something like that. It's kind of leading you to that. If you've tried something like that, where it's a single, a single artifact per Lambda type of project, or if you've done anything else to bring down the artifact size.
I haven't. I think I would try to do. I think I'd try to introduce this Lambda layer piece. There is a way you can share it between multiple Lambdas. Like you have to open up the sharing permissions on it. So I would probably create a new role for that and apply that to that particular set of layers, right? And then so you could have. And you could have multiple layers, right? So you wouldn't have to have them all the same. So you could, you could have some that are tailored for individual parts, right? So, for instance, if you had some dependencies you knew were good for a payment processing engine, right, and maybe you were going to have several different functions with those, then you could have that set of layer that's shared with those. But you might find that you have something like your logging and properties manager that you want to share with, many different applications that are all serverless in your Lambda pieces, right? So you could potentially have those off in their own layer, a whole separate layer, and then pull those in. You can also specify the order, which indicates to me that the ordering may be important. And I apologize, I haven't played with that enough to know on that aspect.
Yeah. So have you found a size limit that you would recommend for a Lambda artifact, where you'd say, okay, this is about as big as you want it to be to get the, to decrease the cold start times and get the response you're looking for?
I have not, unfortunately. Again, I haven't had a lot of opportunity to play with these for our clients yet. But that's a really good question. Maybe one of my colleagues who's on, they may know. They may have had a little bit more experience. If anybody does who's on, we'd certainly love to hear. And Steve, I can also check with some of my colleagues who are not on today and see if I can get back to you with that.
Sure. Yeah.
For
Hey,
instance,
thanks for this is a good presentation, by the way. Thanks a lot.
Oh, thank you. Yeah, I'm sorry. I know I got a little stumbled up there a time or two. It's a little bit hairier than I first thought it would be.
I have a question for you, Ted.
Sure.
Since Lambdas are, deployed on AWS and everything, what's a good strategy for using Lambdas across like different environments, like a staging environment and a prod environment?
Yeah, so I think what you want to do there is utilize the environmental properties. So let me flip back over here if I can. Didn't really go into that today, but you can do in your configuration of your Lambda, you can have things like destinations, your triggers, environmental variables. So you could set some of these up, and actually that's kind of what I was alluding to some with the properties. Is I've been and again, to anybody who wants, I'll share where my repo is a little bit later. But I've been starting to play with reading in properties and the idea of being able to on your runtime start these up and give it a profile effectively. So just like you might would on a traditional application, I think if you have effectively a profile that's going in, you could say, hey, this one's dev. This one is prod, and that would help you with that.
Cool, thank you.
Yep. In fact, Steve may know, because I think Steve's been working with this a bit over the past year or so, and Steve and I used to work together at another place. So yeah.
Nice. I have a question, Ted. First of all, excellent talk. Really well done. Any thoughts on when to not use a Lambda function?
Yeah, I would say if your application is really complex, then it might not be the best bet. In fact, I kind of think where this really probably shines at is when you want to when you've got something that's fairly small in nature, or for instance, let's say you're taking in client data loads for when you're onboarding new clients, right? So it might be useful to write a handful of small functions that will massage that data that you're going to get in from the client, and have those load up into maybe into a like a DynamoDB temporarily, and then on into your traditional relational database, or maybe even your functions go ahead and do that massaging for you. So since you can tie it in with like the S3 pieces, you could easily open up to your clients an FTP drop that's going to your S3 buckets. They could drop in their files. You would have that monitored, and then process those and move those over to a place that lets you know they're done. So I think this would really shine with something like that. Anything that really benefits from some event-driven process and is maybe not super complex in nature.
Right.
Yeah,
I can
because
also,
again, the more complexity you add, the more you have to start thinking about, what does each of the functions do, and you're going to want to have that, probably well diagrammed and well documented, so that you know where to go if there's a problem. So, but while that seems like it could be a problem, there's also potentially a benefit there in that, if you if one little section function is down, you could, in theory, go just make your code changes to that and deploy just that one function, and really limit your downtime. So that is a possible benefit.
yeah. Also, I can think of like anywhere if there is any idle time, like if you're using any functions as orchestrators, which are like calling other services and functions,
Right.
doing coordination work. So then using Lambda function can result in some idle time, and then that will increase the cost. So yeah, that could be something you can use, something like a step function in there.
Oh yeah, for sure. Right. Yeah, and with some of the stuff that Steve and I used to do together, I can think of like some of our cleanup of some old files might have benefited from this, or the step functions where you could throw them into this. It could scale out as needed. It's handling the reading through the file, parsing it, do what it needs to do, and at the same time it's fairly simple, and then it sends an update to the master database, or queues up an update to it. So yeah, I think it's really nice from a scalability standpoint for sure.
Yeah. Nice. Thanks, Ed.
Yeah.
Any other questions? Anyone else?
Hey, Ted, I have a question.
Okay.
I mean, how is the runtime of Lambda managed? Because I was just thinking on the lines, I mean, if there happens to be an exception which is unrecoverable, right? How does it handle then after?
Oh, okay, yeah. So most of your exceptions will be logged out. Let me flip back over here. And let me flip over to, we're going to go to CloudWatch. Well, I say that actually, you're going to have a monitor here on your Lambda. So here you can see some CloudWatch metrics that are already built in. And then you're going to see those log out over to CloudWatch, where you can look at in more detail. And,
Yes.
and this is their default piece. You can have some alarms set on here, and you can have it set up to alert you. So we've got some different pieces here that we can see all the events. Now, obviously, it's going to depend on how much you're logging out. So you're going to want to capture certain amounts of data. So here, actually, you can see a class not found. So you may recall earlier I said you have to watch where your layer goes. Because if you don't have your layer in the right class path, then you're going to get like this class not found exception. So this is a perfect one right here. So it said it couldn't find the save automobiles handler, right? And that was because I didn't have the library in the right place.
So logs are the ways to trace the error, but what happens to the Lambda itself? I mean,
The Lambda itself.
Like,
I mean,
if you imagine if you are running a Spring Boot application, which is for some reason, if it crashes, right? Some error that is like divide by zero
I got
error
you.
or something of that can happen. It generally shuts down the server, right? With exit one.
Yeah.
So now, in case of Lambda, what happens?
That's a really good question. I unfortunately I don't know. I think you would have a bunch of calls to it that are crashing, and that unfortunately it would just keep crashing. But I would be willing to bet that there is a way to through your alarms and monitoring to roll back to a previously working version if you have such. But if you don't, then I mean it could definitely be a problem. So that's a
In your
really great
last
question.
Cloud Propel workshop, so you basically introduced Lambda, right? So I mean, any exception that occurred in when the on handler the function was called. So the next time, if there was an error which was not recoverable, I was still able to call that function again. So meaning, is it spinning up a new version of Lambda function, or is it?
Well, it's not going to spin up an entirely new version every time, but I would guess if that instance completely melted down, I guess I would expect it would. So that would actually be an interesting little workshop to put together, is to see if we can purposely break it and then see what happens. Like if it keeps spinning up new ones, that is a really good thought process to go through and try out. Yeah, great question.
We can try that.
Yeah. So we'll, you know what, I'm gonna put that down for to bring up in our next practice meetup and see if we can get a few people to build something out to simulate that.
It's a great idea.
Okay.
Yeah.
Cool. Thanks, Ted. Thanks, Nikhil. Any other questions? Anyone else?
I have a question. First, thank you, Ted, for great presentation. And about previous question, as I know, when instance of Lambda crashed, AWS handled of this and create another one. So it's shouldn't be a problem. But my question about cold start, you mentioned it today.
Yes.
I worked with Lambda on one project a few years ago, and I faced this situation. And cold start is not big deal, but at the time the issue was a little bit worse, because when Lambda started, it was cold start, but if some period was not another call, it became cold again. As I remember, it was 5 minutes or 3 minutes. If no one call, AWS clears the memory and your Lambda became cold again. So I was forced to keep it warm using additional loop to call periodically the Lambda to keep it warm. So my question is did you face this situation, and is there a strategy now to keep it warm?
So I know over the past few years, the folks at AWS have done a lot to help Java in particular load up a bit faster. I think historically it has been a bit slower to start up than most of the other languages on that code start. And that's often been a complaint. And like I said, I believe they've done some work that helps make that a little bit faster. I know I don't know the strategies right off my top of my head right now. I remember reading some a couple years ago about helping it keep from being the code start. And so I do know there's some places in here where you can go in here and talk about your state machines, I believe. Or sorry, not state machines. Sorry, I was trying to think. I remember seeing there was a place where you can specify like memory and so on. And so it may have a way for you to specify your timeout. But yeah, actually, let's hear our general configuration, right? So we can give how much memory. We may be able to even say in here like how quickly we want that start to change. Right here, actually, snap start. So it says reduce startup time of our Lambda cache, right? So it's got some piece built in here to help us out. So we can look at that.
Hey Ted, there's also reserved currency. I don't know if so reserved, it's like reserved concurrency. What you do is you can specify the number of lambdas you want to keep warm.
Nice, yeah.
You're going to pay for it, but
sure.
You get warm lambdas instead of cold, and they stay warm.
Yeah, now that you mentioned that, I remember seeing. I was looking at the pricing a bit earlier today, in fact, and I remember seeing there was additional pricing for that. So they introduce different pricing tiers based on how warm you want to keep it, basically, right? So, or how available.
There is also a new feature. I haven't used it, but they just released it like a month ago. It's called Snap Start, and the way it works is if you enable it on Lambda, and then when you run the Lambda function for first time, it will do the standard initialization, and then after that it creates an encrypted snapshot of the memory and the disk state, and then the cache that for reuse, and then when that function is invoked again, Lambda will grab the cache and start up the function. So it's very fast. It solves that problem. So that's something that you can look up as well.
Right. And I think that's what this is. We were seeing here on the basic settings now that you have is that you can increment that, and it's So that definitely is a good thing to look at. And I know earlier, Steve, this may go back a little bit to your question. I didn't show this earlier because I didn't show setting up the Lambda, but I had applied it to a role, right? So you establish what role you're going to have that run at. So it sounded to me like you were maybe creating a role per Lambda, and you may have cases where you actually want to have one role that works with multiple lambdas, right? So, and you can do that. That's what I've done for a lot of my workshops. Is I just created a one I wanted to utilize for test purposes, but you could definitely have multiples. And so if I had different ones here, I could select from those, right? All right. Well, great questions, everybody. I'm sorry I wasn't able to answer a lot of those. Those are really great ones, though.
No, but this is good.
I think. I was gonna say what I think this shows is there's a whole lot here. It's like a really big onion, lots of layers, and not just Lambda layers, but lots of layers to what you can do with Lambda. So it's definitely worth checking out.
Nice.
Yep.
Thanks a lot, Ted. Excellent presentation, and then great discussion. Thank you all for all the questions. Next week, we have Jacob Gerald, who is a senior mobile engineer with us. He's going to give us a primer on Android Studio and how to get most out of it. So I'm looking forward to that talk. So make sure you mark your calendar for next week. And thank you all once again for joining. Have a wonderful evening, and I'll see you guys next week.